Dear students, let's continue from where we left in the last class. Let's have a look at question number 127. If f of x is equal to, they have given this determinant, then what is f dash of x? Okay. So, f of x is equal to determinant of x, x square, x cube, 1, 2x, 3x square, 0 to 6x. Okay. So, first we shall simplify this, we shall evaluate the value of this determinant, we shall find out what is the value of this determinant. After that, we will differentiate it to get f dash of x. That is one way of solving this problem. Or else, if you want to differentiate a determinant, that also can be done, that is by differentiating one row at a time. So, first row we have to differentiate by keeping second and third rows as it is, plus write another determinant where you are differentiating the second row, thereby keeping first and third rows as it is, plus one more determinant where you will differentiate the third row keeping the first and second rows as it is. That is one way of solving it, but that is time consuming as far as this problem is concerned. So, I will go for the expansion of this determinant and then I will differentiate. Okay, before I expand, I will take x as a common factor from say from the first row I am taking x as a common factor. So, if I take x out from the first row, then we are left with 1x x square, and here you have 1 2x 3x square, 0 to 6x. Again, from the third column here, you observe x is a common factor here. Okay, what is this? Okay. Say from the third column, I will take x as common. That means you will have x square into determinant of 1 1 0 x 2x 2. Here I have taken x out, so x 3x and 6. Now expand this determinant, x square into 1 into, here you get 12x minus 6x, which is 6x, minus x into 6 minus 0, which is 6, plus x into 2 minus 0, which is 2. So, we get x square into, here 6x gets cancelled, you will have 2x here, together it will become 2x cube. So, we have f of x equal to 2x cube. The question is to find out f dash of x. Differentiate this, we get 6x square, which is the fourth option. Okay. Then 130. If root of 129. If delta 1 is equal to determinant of x a b x a b b x, and delta 2 is equal to x a b x, that determinant, then what is d by dx of delta 1 in terms of delta 2? That is, derivative of delta 1 is it equal to delta 2, or derivative of delta 1 is it equal to 3 into delta 2, or derivative of delta 1 is it equal to 2 delta 2, or is it 0? 0 means actually it should have been d by dx of delta 1 equal to 0. Okay. So, for that, let us expand both of these two determinants, delta 1 and delta 2. Delta 1 they have given determinant of x a, b x a, b b x, that is equal to, I will expand this determinant, x into x square minus ab minus a into bx minus ab plus a into b square minus bx. This will give us, simplify, x cube minus abx minus abx plus a square b plus ab square minus abx. Together we get delta 1 is equal to x cube minus 3abx, here abx minus abx, altogether it will become minus 3abx plus a square b plus ab square. This is delta 1. Now differentiate this. D by dx of delta 1 is equal to 3x square minus 3ab. Derivative of 3abx is 3ab. 3x square minus 3ab. See, we want the derivative of delta 1 in terms of delta 2. What is delta 2? Delta 2 is determinant of x a b x, which is equal to x square minus ab. X square minus ab. Here I will take 3 as common. So 3 into x square minus ab. X square minus ab, I will replace it with delta 2. So we get 3 delta 2. D by dx of delta 1 is equal to 3 delta 2, which is the second option. Okay, now let's have a look at 130. Question number 130. If root of tan y is equal to e power cos 2x into sin x, then what is dy by dx? Root tan y is equal to e power cos 2x into sin x. Root tan y, I can write it as tan y to the power 1 by 2. That's equal to e to the power cos 2x into sin x. I'll take log here. Taking log on both sides, that will give you log of tan y to the power 1 by 2, or I can write it as 1 by 2 log tan y. That's equal to, here we get log e power cos 2x into log sin x. Sorry, log of e power cos 2x into sin x. Log mn can be written as log m plus log n. So log m plus log n, that will be log sin x. Okay, then half log tan y is equal to log of e power cos 2x is nothing but cos 2x. As you know, log e power f of x is equal to f of x, or you can write log m power n, that's equal to n log m. You can write this as cos 2x into log a. Log a is 1, so it will be cos 2x plus log sin x. Now let us differentiate this. Differentiate this again with respect to x. So derivative of half log tan y is 1 by 2 into 1 by tan y into the derivative of tan y, which is secant square y into y dash. That is equal to derivative of cos 2x, that is minus sin 2x into 2, plus derivative of log sin x is 1 by sin x into cos x. Okay, let us simplify this. Secant square y, I will take it to the denominator. When it goes to the denominator, it will become cos square y. And here tan y is there, I will write it as sin y by cos y. So we are left with 1 by 2 sin y cos y into y dash. See here, secant square y, I am writing it as 1 by cos square y. Sin y, tan y as sin y by cos y. One of those cos y gets cancelled. So you have 2 sin y cos y into y dash is equal to minus 2 sin 2x plus cot x. Cos x by sin x, it will become cot x. So y dash is equal to, this 2 sin y cos y is nothing but sin 2y. Take it RHS, sin 2y into this factor. I will write this term first. Cot x minus 2 sin 2x. This is our y dash. Sin 2y into cot x minus 2 sin 2x, which is the first option. Okay, next. 131. X is equal to cos theta, y is equal to sin 5 theta. Then 1 minus x square into d square y by dx square minus x into dy by dx is equal to. Okay. Here, even though the function is expressed in parametric form, you can eliminate theta from these two equations. From the first equation, you have x equal to cos theta. From there, I can write theta is equal to cos inverse x. So that y can be written as y is equal to sin 5 theta. I am writing it as sin of 5 cos inverse x. Theta, from the first equation, we have x equal to cos theta. From there, I am writing theta is equal to cos inverse x. Theta is equal to cos inverse x means y is equal to sin of 5 cos inverse x. Okay. Right. Now, we are asked to find out 1 minus x square into d square y by dx square. I will write it as y2 minus x into dy by dx, which is y1. So, 1 minus x square into y2 minus xy1 is equal to what? That is what we have to find out now. So let us differentiate this with respect to x. So when I differentiate, y1 is equal to cos 5 cos inverse x into 5 into the derivative of cos inverse x, which is minus 1 by root of 1 minus x square. Okay, cross multiply, bring that root 1 minus x square to this side. So that will give you root of 1 minus x square into y1 is equal to minus 5 cos inverse x. Now differentiating this again with respect to x, that will give you root of 1 minus x square into y2, I am using product rule here, plus y1 into, now the derivative of root 1 minus x square, which is 1 by 2 root of 1 minus x square into minus 2x. That's equal to, on RHS, minus 5 into derivative of cos x is minus sin x, so it will become 5 sin 5 cos inverse x into 5 into the derivative of cos inverse x, which is minus 1 by root of 1 minus x square. Now multiply this equation by root 1 minus x square. When I multiply by root 1 minus x square, this will become 1 minus x square into y2. Here root 1 minus x square gets cancelled, 2 also gets cancelled. So you have minus xy1. On RHS, root 1 minus x square we have brought here. So we will be left with minus 25 sin of 5 cos inverse x. Okay, sin of 5 cos inverse x can be replaced by y. So the answer is minus 25y. Minus 25y, which is the fourth option. Then 132. If y is equal to sin log x, then x square d square y by dx square plus x dy by dx is equal to. Okay. Given y is equal to sin log x, then we are asked to find out x square into d square y by dx square. I will write it as y2. y2 is another notation for the second derivative, d square y by dx square, plus x into dy by dx, dy by dx I will write as y1. Okay. Given y is as a function of x, we want to find out what is x square y2 plus xy1. Okay. So we need to differentiate it twice, obviously. Differentiate once. We get y1 is equal to derivative of sin log x is cos log x into the derivative of log x, which is 1 by x. Now cross multiply, that will give you xy1 is equal to cos log x. Now again differentiating with respect to x, again, that will give you xy2 plus y1 is equal to minus sin log x into 1 by x. Cross multiply, bring that x here, that will give you x square y2 plus xy1 is equal to minus sin log x. What is sin log x? Sin log x is y. Therefore, we get x square y2 plus xy1 is equal to minus y, which is the fourth option. Next, 135. Let f of x is equal to x power n being a positive integer. The value of n for which f dash of a plus b is equal to f dash of a plus f dash of b, where a and b are positive, is given f of x is equal to x power n. We are asked to, n is a positive integer, okay. We are asked to find the value of n such that f dash of a plus b is equal to f dash of a plus f dash of b. We want the value of n such that f dash of a plus b is equal to f dash of a plus f dash of b. Okay, find out f dash of x. F dash of x is equal to n into x power n minus 1. Okay, then I will consider that equation, f dash of a plus b is equal to f dash of a plus f dash of b. F dash of x is n into x power n minus 1. So, f dash of a plus b will be n into a plus b to the power n minus 1 is equal to f dash of a. F dash of a is n into a power n minus 1. F dash of b is n into b power n minus 1. We can divide by n, n gets cancelled here. So that will give you a plus b to the power n minus 1, that's equal to a power n minus 1 plus b power n minus 1. Okay, we want the value of n which will hold good for this equation. We will go for trial and error. Put n equal to 1. If I put n equal to 1, I am getting here power 1 minus 1, that is 0. A plus b to the power 0 is 1. LHS will be 1. But on RHS, 1 minus 1 here 0, a power 0 is 1. Similarly, here b power 0 is also 1. LHS will be left with 1 and RHS is 2. They are not equal, right? So 1 cannot be the right answer. Put n equal to 2. If I put n equal to 2, here a plus b to the power 2 minus 1, that is 1. A plus b whole power 1, here we get a plus b. Here a power 2 minus 1, which is a. Here b power 2 minus 1, which is b. So a plus b is equal to a plus b. So for n equal to 2, the result holds good. Hence, that's the answer. 136. If f of x is equal to modulus of x minus 2, then g of x is equal to f of x. Then for x greater than 2, what is g of x? Okay, see, it is given that f of x is equal to modulus of x minus 2. We know how mod x minus 2 is defined. It is equal to x minus 2 if x is greater than or equal to 2 and 2 minus x if x is less than 2. Okay, this is how it is defined. Mod x, you know, mod x is equal to x if x is positive and minus x if x is negative. So mod x minus 2 is equal to x minus 2 if x minus 2 is positive. X minus 2 is positive means x is greater than or equal to 2 and it is 2 minus x when x is less than 2. But here it is given that x is greater than 2. Therefore, I can directly write f of x is equal to x minus 2. Okay. Now, coming to this question. G of x is defined as f of x. That means f of x I will write it as x minus 2. F of x minus 2. F of x is x minus 2. So, f of x minus 2 will be x minus 2 minus 2, which is x minus 4. This is g of x, right? G of x is equal to x minus 4. Question is find g dash of x. G dash of x is equal to 1. Second option. 138. If g of x be the inverse of f of x and f dash of x is equal to 1 by 1 plus x square, then what is g dash of x? That's the question. Okay. G of x be the inverse of f of x, which means f inverse of x is equal to g of x. They have given. G of x is the inverse of f of x. So, f inverse is equal to g. Then f dash of x is equal to 1 by 1 plus x square. F dash of x equal to 1 by 1 plus x square they have given. Then what is g dash of x? That's the question. Okay. So, let us go back to our first chapter, which is relations and functions. Do you remember anything from that chapter now? Yes, little bit, right? Okay. Say f inverse is equal to g. So, you just think of the problems like where we had solved problems like prove that if f is defined from R to R defined by f of x equal to so and so, prove that f is invertible and hence find f inverse. Such questions you have solved. There what did we do? How did we prove it? We had defined another function g from codomain to domain such that g circle f of x is x and f circle g of y is equal to y. That is what we did. We proved that g circle f is identity and f circle g is also identity. Or you just recall the definition of inverse. We say that a function f is invertible if there exists another function g such that f circle g is identity and g circle f is also identity. Okay. So, now if f inverse of x equal to g of x means f circle g must be equal to an identity function. F circle g is identity means f circle g of x is equal to x. What do you mean by identity? Identity means the image of every element is that element itself. So, f circle g of x is equal to x, which means f of g of x is equal to x. Okay. Given that f inverse of x is equal to g of x, that will imply that f of g of x is equal to x. Now let us differentiate this with respect to x. Differentiating this function with respect to x, we get a f dash of g of x into g dash of x, okay, is equal to 1. The derivative of x is 1. F dash of g of x into g dash of x equal to 1. Okay, look at this. It is given that f dash of x is equal to 1 by 1 plus x square. F dash of x is 1 by 1 plus x square. Therefore, f dash of g of x is 1 by 1 plus g of x whole square. Okay, f dash of x is 1 by 1 plus x square. So, f dash of g of x is 1 by 1 plus g of x whole square into g dash of x is equal to 1. This will imply that g dash of x is equal to 1 plus g of x whole square. G dash of x is equal to 1 plus g of x whole square. That is the answer, which is the second option. So, you remember this, that is, whenever g is the inverse of f or f is inverse of g, then we can write f inverse of x equal to g of x and g inverse of x is equal to f of x. If that is the case, then immediately you should be able to write that f circle g is identity and g circle f is also identity. Then 139th question. If dy dx of 1 plus x square plus x power 4 divided by 1 plus x square is equal to ax plus b, then what is a and b? You can factorize this, right? Say 1 plus x square plus x power 4, we can write this as two factors. One is 1 plus x square and the other one is 1 minus x plus x square. You must have studied this in your high school, you might remember. Do you remember this formula? 1 plus x square plus x power 4 can be written as 1 plus x square into 1 minus x plus x square. Okay, I think you know this formula. Should I expand and prove this? What do you think? Okay, as you wish, I will show that how this is equal to this. Let us simplify. You just multiply this. What do you get? 1 minus x plus x square plus x minus x square plus x cube plus x square minus x cube plus x power 4. Okay, I am just multiplied them. See what happens. Minus x plus x gets cancelled. X square minus x square gets cancelled. X cube minus x cube gets cancelled. Then what will remain here? We are left with 1 plus x square plus x power 4. Right? 1 plus x square plus x power 4. Okay. So, now coming to this problem, here they have asked us to find the derivative of 1 plus x square plus x power 4 divided by 1 plus x square. Now, what I am doing here is, I am writing this numerator 1 plus x square plus x power 4 as 1 plus x square into 1 minus x plus x square. So, there 1 plus x square gets cancelled, then we are left with dy dx of 1 minus x plus x square. Okay, this factor gets cancelled. Now, you differentiate it. When I differentiate this, I am going to get minus 1 plus 2x, or you can write this as 2x minus 1. On RHS, there we have ax plus b. On comparison, we get a is equal to 2 and b is equal to minus 1. A is 2, b is minus 1, which is the third option. 140. F of x is equal to 1 if x is negative, 1 plus sin x if x is between 0 and pi by 2. Then the derivative of f of x at x equal to 0 is. Okay. As you can observe, one of the options is does not exist. If it does not exist option is there, you should be very careful. You have to cross check whether it exists or not. Okay. So, now we are asked to find the derivative of f of x at x equal to 0. Before finding the derivative, since it does not exist option is there, we will find the continuity also. Just check whether it is continuous or not at 0, because if the function is discontinuous at 0, then directly you can say it is non-differentiable, because if a function is differentiable means it has to be continuous, right. So now we will cross check first whether it is continuous or not. To test continuity, I have given you one formula. For left hand limit, directly you substitute the limit value here, and for right hand limit, directly substitute the limiting value here. So x approaches 0. For left hand limit, put x equal to 0 here. So left hand limit, put x equal to 0, we get put x equal to 0, there is 1, so 1 will remain as 1 only. And for right hand limit, put x equal to 0 here, we get 1 plus 0, which is 1. Left hand limit is 1, right hand limit is 1, therefore the function is continuous at x equal to 0. Okay, continuity, all right. Now I want to test the differentiability. How do I differentiate it? I have told you how to do it. F dash of x, you directly differentiate, here 0. Okay, here what happens? 0 when x is less than 0. Here you differentiate, derivative of 1 plus sin x is cos x, derivative of 1 is 0, derivative of sin x is cos x. That is when x is greater than 0, less than or equal to pi by 2. Okay, greater than 0, because at 0 we don't know. Now to test whether it is differentiable or not at 0, what you have to do is put x equal to 0 in both the cases. Here when I put x equal to 0, I have 0 only, okay, whatever I substitute I will get 0 itself. And here if I put x as 0, I am getting cos 0, which is equal to 1, which suggests that left hand derivative is equal to 0 and right hand derivative is equal to 1. Left hand derivative is 0, right hand derivative is 1, therefore the function is not differentiable at x equal to 0. Hence the answer is does not exist. 141. If y is equal to 1 plus 2x plus 3x square plus 4x cube etc. up to infinity, then dy by dx is equal to. Observe that RHS, you have the expansion here 1 plus 2x plus 3x square plus 4x cube etc. up to infinity. Then what is dy by dx they are asking. Look at this RHS, this is the expansion of 1 minus x whole power minus 2. You must have studied this in binomial theorem. In PSC not there, but in CET also very rarely they ask this, but for mains you need to remember, okay. So it's very unlikely that this question will be asked in CET. However, during binomial theorem you have seen that the expansion of 1 minus x whole power minus 2 is equal to 1 plus 2x plus 3x square plus 4x cube etc. So this is the expansion of 1 minus x whole power minus 2. This you have to remember. Okay. Now differentiate it. Y dash is equal to minus 2 into 1 minus x to the power minus 3 into minus 1. So it will become 2 divided by 1 minus x whole cube. I am bringing it to denominator. Minus 2 into minus 1, it will become plus 2, and here 1 minus x whole power minus 3 is there. Take it to denominator, 1 minus x whole cube. 2 by 1 minus x whole cube, which is the third option. Then 142. dy by dx of e power e plus x power e power x and plus e power x. Okay, here we have to find the derivative of the sum of these three functions. I will treat this problem as three separate problems. Okay, I will consider e power x power e power x and e power x separately, and I will differentiate all three separately, and finally we will add those three derivatives to get the answer. Okay, so first problem I will take, let y is equal to e power x power e. Okay, now y dash is equal to the derivative of e power x power e, it is just like e power x. Derivative of e power x is e power x itself. So derivative of e power x power e is e power x power e into the derivative of x power e. What is the derivative of x power e? E into x power e minus 1. So this is equal to e into e power x power e into x power e minus 1. Okay, this is the derivative of the first term, right? Now I will take the second term, I will call it as y again, or if you want I will take it as u. Okay, u, I will take y, u and v, or u, v, w, whatever you want you take, but don't take x, already there is an x. So u is equal to x power e power x I will take. Okay, x power e power x, this is one function, I will treat x as one function and e power x as another function. So this is how the form y is equal to f of x to the power g of x. If y is equal to f of x to the power g of x, then dy by dx, you know one direct formula. What is the formula? Dy by dx is equal to y into g of x into f dash of x by f of x plus g dash of x into log f of x. That formula you know. So, I do not have enough space to write that formula again here. So, we have discussed it on many occasions. So, you should be knowing it. So, that it is of that form, I will treat f of x as x and g of x as e power x. So, now du by dx is equal to y means here u, which is x power e power x, into, what is the formula? Into g of x is e power x, into f dash of x is x, so f dash of x is 1, by f of x, which is x, plus g dash of x is e power x, derivative of e power x is e power x itself, into log f of x, that means log x. Okay. So, now I will take this e power x as common. So, you have x e power x into e power x into 1 by x plus log x. Okay. Then that third term is there. I will take that as v. V is equal to e power x. Okay. Now, what is dv by dx? This is equal to, say, e power x, you can treat this as it is in the form e power x. Derivative of e power x is e power x itself. Then derivative of e power x is e power x into the derivative of x power x. Derivative of x power x. To get the derivative of x power x, again it is of this formula that I am going to use. Okay. So, e power x into the derivative of x power x, it is of this form, f of x to the power g of x. There what do we do? Y is what here? X power x into g of x is x, f dash of x 1 by f of x plus g dash of x is 1 into log f of x, log x gets cancelled, e power x into x power x into 1 plus log x you get. Okay. Now, add all three. This is, call it as equation 1, this is equation 2 and this is equation 3. Add these three, you will get the answer. First term is e into e power x power e into x power e minus 1 plus x power e power x plus into e power x into 1 by x plus log x plus e power x into x power x into 1 plus log x. Observe, this third option is the correct answer. Okay. Then 144. If a power y is equal to log x square plus x plus 1 to the base a, then dy by dx is equal to, say, while differentiating log x, we prefer that the base is e, right? Now, the base is a, so I will use change of base rule and write this as log of x square plus x plus 1 divided by log a. Okay. Here base I have changed it to e and I have not mentioned it, then that means we must understand that the base is e. Cross multiply, a power y into log a is equal to log x square plus x plus 1. Now, differentiate this with respect to x. Differentiating with respect to x, this log a is constant. Derivative of a power y is a power y into log a into y dash. Into that log a is remaining, so together it will become log a whole square into y dash is equal to. Derivative of this expression is 1 by x square plus x plus 1 into 2x plus 1. Okay. Now, look at the options. If I take all of these to RHS, we should get the answer, but look at all the options. Everything is in terms of x only. None of the options contain y, right? So, we have to eliminate y from this. I will replace a power y with this. A power y, I will write it as log x square plus x plus 1 by log a. Okay. So, log x square plus x plus 1 by log a I will write. Into log a whole square is there. So, one of those log a gets cancelled. So, into log a into y dash is equal to 2x plus 1 divided by x square plus x plus 1 will remain. Now take it to RHS. So y dash is equal to 2x plus 1 in the numerator, that is okay. Denominator x square plus x plus 1 into log of x square plus x plus 1 into log a, right? This log a I have taken there. 2x plus 1 by x square plus x plus 1 into log x square plus x plus 1 into log a. So this is okay, but log a is missing here. This is not okay because 2x plus 1 itself is not there. Here also 2x plus 1 is not there. This is the one which is closer to the answer. But here you observe 2x plus 1 by x square plus x plus 1 into log x square plus x plus 1. All of those are available. Only thing that is not available is log e to the base a. Here base I have not mentioned, which means it is log a to the base e. Now I will take it to the numerator. When log a to the base e goes to the numerator, it will become log e to the base a. So I can take it to numerator and write this as this into log e to the base a, which means first option is the correct answer. Okay, let me solve one more problem before I stop this class. Question number 145. The derivative of the function f of x is equal to root of x square minus 2x plus 1 on the interval 0 to 2 is. Okay, now f of x is equal to root of x square minus 2x plus 1, I will write as x minus 1 whole square. So root of x minus 1 whole square is equal to mod x minus 1. The question is, what is its derivative? You know where it is not differentiable. The question is, what is its derivative in this interval? Okay, say mod x minus 1 is actually defined as x minus 1 when x is greater than 1, 1 minus greater than or equal to 1, 1 minus x when x is less than 1. At 1 it is not differentiable, everywhere else it is differentiable. We can write like this, f dash of x is equal to 1 if x is greater than 1, minus 1 if x is less than 1. At 1 not differentiable. So there they have asked us to find out what happens in the closed interval 0 to 2. 0 to 2, this interval contains 1. So at 1 this function is not differentiable. As you know, mod x is not differentiable at x equal to 0. Similarly, because of the same reason, mod x minus 1 is not differentiable at x equal to 1. So 1 is present in this interval, therefore we have to say, even though in that interval there are infinitely many points, among those infinitely many points only at one particular point it is not differentiable, everywhere else it is differentiable, but still we will say that the derivative does not exist in that interval, because 1 belongs to that interval, at 1 it is not differentiable, therefore derivative does not exist in that interval. Okay, this is one way of solving this problem, that is if you identify that root of x minus 1 whole square as mod x minus 1, okay. If you directly write this as x minus 1 and differentiate, you will write 1 as the answer, okay, which is not correct. But if you think, sir, if I don't know all these things, how do I, is there any chance that still I will get the right answer? Yes, there is a possibility. See, whenever you see does not exist, you must be very careful. So when I say you must be very careful, don't think that always we should tick that as the correct answer. May not be, okay, but you should be cautious whether it exists or not. At every point you have to check. So okay, you directly go for its differentiation, derivative, 1 by 2 root of x square minus 2x plus 1 into the derivative of this is, which is 2x minus 2, okay. Now in this interval you substitute all the point and check which point I will take. I will take 1. If I put x as 1, 2 minus 2, numerator is 0, denominator 1 minus 2 plus 1, denominator also 0. So 0 by 0, this is not defined. Now when I say 0 by 0, don't think of, sir, I will use L-Hospital's rule. Okay, you cannot. You can use L-Hospital's rule only when you have a limit here, okay. So this is 0 by 0, an indeterminate form, this is not defined. So f dash of x is not defined at x equal to 1 and 1 belongs to this interval, therefore function is not differentiable in that interval, or a derivative does not exist in the interval 0 to 2, okay. Thank you. With it I will conclude today's class. Thank you.